So, when you factor, if you have four terms, if you have four terms, you take out the x squared, you'll get x plus 6. Now, again, I didn't say it, and I should have said it, but you must look for anything common to all four before you start. Like, that is always the first step, and I always forget to mention that. I told the class yesterday, it's almost like stretching before you exercise, that it kind of goes without saying, but most people don't do it. All right? 8 is common to both of these two pieces. 8's common to both 8 and 48, so that will come out. It is x plus 6. Once you get to there, x plus 6 is common to both. And what you have left is x squared plus 8. All right. Any questions on the first one?
Wow, you would have told us that yesterday. I'm not saying
I did tell you that, actually. I did tell you that, actually.
You did?
Yeah. Erica, did I tell you that last time? To make sure you take out the common factor that's common to all of them? Okay. All right. Now, again, looking at all four, there's nothing common to all of them. So I will take that out. And I know for sure I did, actually. 100% positive I did. 2x minus 5. Here, I'm taking out a negative 4. I will get 2x minus 5. The 2x minus 5 is common to both, so I will pull that out. And what I have left is x squared minus 4. Now, here's the issue, and it didn't happen in the last problem. This problem you cannot continue because this is x squared plus 8. But with this problem, you can continue because x squared minus 4 is the difference of two squares. And you'll get 2x minus 5, x plus 2, x minus 2. And so that one has to continue. Now, your task is going to be able to see it and recognize that it continues, because if you don't continue, it's going to be the wrong. I mean, you don't get partial credit. It's not, hey, I was close. None of that. It's either you get the right answer or you don't. And if you don't continue, you don't get the right answer. Now, again, just to reiterate, you don't continue with this because of two reasons. Number one, this is not a minus sign. And number two, this is not a perfect square. Now, if it were a plus sign and it was a cube, then that might be a different thing of problems that we haven't discussed in this class yet. We have discussed in some other ones, but we haven't done it here yet. We're doing it in a little bit. But generally, we're looking for perfect squares, and that's not it. A problem like this is as straightforward as they could ever get. Like, if you see a problem like this on test day, for those of you that count blessings at night, count that twice. Just start and end with that thing. This is the difference of two squares, and that is simply x plus 5, x minus 5. And the reason I know that we discussed it is I think we worked on a problem that looked like this, where we had 4x squared minus 16. And I told you got to take out a common factor. All right. Holy moly. Who's got this? Now, this one is, what's common to both terms? Y. What else? Is 24 going to both? And what are you left with? X squared minus 9? 9y squared, yes? Do we have to continue? If this is a perfect square and this is a perfect square, then you have to continue. Are they both perfect squares? And some people are going like this. No. Yeah, they are. This is x plus 3y, x minus 3y. Any questions on that? All right. As we do number 5, you've never seen number 5, so I'm going to kind of walk you through the idea and then I'll give you some more to practice. This is what we call the sum of two cubes. And the reason why I call it the sum of two cubes is this. It is because some number times itself gives you x cubed, and then a different number will give you 8. And the two things we're dealing with are, for the first one, for the x cubed, that is x. X times x times x gives me x cubed. 2 times 2 times 2 gives me 8. And so in order to factor this, it's a small parenthesis and a large parenthesis. And I'm going to show you how to do it. And it's not anything that you would look at, Trevor, and go like this. Oh, I would have gotten that. No. What I'm about ready to show you, no one ever looks into. Like, you have to be shown how to do it. And if not, you probably don't get it. But here's the way it works. Whatever sign you have here, that sign goes here. Now, these two pieces form the base of everything else that we do. So everything works off of these two things right here. And I'm sorry, I have a habit of pointing to the damn screen like everybody can see what I'm pointing at. These two pieces form the base of everything that we do. So everything we do, we go back to the x and the 2. So for the first set of parentheses, we just write them both down. X and 2. For this piece, we're going to have 3 pieces. 1, 2, 3. The first piece is x times x. It's just whatever this is times itself. X squared. The last piece is whatever this is times itself. So 2 times 2 is 4. This sign for the middle term has to be different than this one. So if this one's plus, this one has to be minus. If this one were minus, this would have to be plus. Now I'll explain to you why in a second. Okay? These two pieces multiply by each other, x times 2, and that forms this middle number. X times 2 is 2x. That last sign will always be a positive. Now, let me explain something to you. I just told you that this multiplies to give you this. First of all, let's verify it. X times x squared is x cubed. X times minus 2x is minus 2x squared. X times 4 is 4x. Does everybody agree with that? Now, 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. 2 times 4 is 8. When I add straight down, x cubed, there's nothing there, so that's just x cubed. Negative 2 plus 2, what happens? That cancels. Plus 4 minus 4, what happens? Cancels. And you get x cubed plus 8. Now understand, Holly, that just me showing you that it works doesn't make it terribly obvious as what the hell you're supposed to do. I mean, all it basically does, Holly, is just confirm that I was right to start with, which I didn't really have to even confirm with you. You probably would have just assumed anyway. Fair enough? If this sign is not different than this sign, let's say that both of these signs are positive, then what happens is all of this stuff becomes positive and nothing will cancel. Does that make sense? So this sign and this sign cannot be the same, because if they were, then all of these signs would be the same and nothing would cancel. So that's why if this one's plus, this one's got to be a minus in order to get them to go different. And if this one's a minus, this one's got to be a plus in order to get them to go different. You're fine. No one hears it anyway. Now, that's why those two signs have to be different. Now, that doesn't necessarily explain to you why I have to take this number times itself to get this value. Why is that? Well, this times this has to give you that number, yes? So if we used one of them here, then we need two of them over here. Does that make sense? Because remember, we said x times x times x. I took one of the x's and put it here. Well, then the other two have got to go there. And that's why you square it. I said that 2 times 2 times 2 gives me 8. I put one of the 2's here. So what does that leave? 2 of them to go there. And that's why you square that middle number. Now, the part that's not obvious at all is why the hell do you just multiply those together? Like, that just seems convenient. Well, I'll tell you why you do it. Because it works. That's why you do it. Yes. It came from this piece times this piece. So whatever that middle number is, it's this number times this number. Okay? So let's take a look. And I'll walk you through this one and I'll give you one to try. If I say x cubed plus 125. Now, here's the thing. If I ask you what number times itself gives me x cubed, I think everybody knows that's x. If I say what number times itself gives you 125, look, I ain't hating on y'all, but some of y'all be just playing bingo. You just be calling out numbers. 6? 5 or 15. People go like this, that shit can't be 6. At least you know it can't be 6. All right. I'm going to do something that I don't generally do, which is going live and typing in something that I'm not sure. Perfect. Perfect. On your calculator has either this button, which is a cube root button, Or at the very least, it has a button that's like this. Okay? If you have this button, then you just press it. You hit second and you press that button. If you don't have that button, you would press 3 and then hit second and hit this button. Fuck this stupid ass thing. I sure as hell would like to have a damn calculator that worked with this shit. This is as good as we get. Where? Anyway, you know what I'll do? I got an idea. How many of you have a calculator that looks like this one? If you had this one, oh, you son of a... If you have this one, which is very similar to what I give you in class for the test day, it would be 3 and hit second and hit this caret key. Second and hit that caret key. So you'd hit 3 first, second, hit that caret key, and that will give you, the way it would type in is it would look like this. 3X, and then it'll just ask you what you want to type in. Type in 125 and press enter. And when it does that, it'll display out 5. Does everybody see that? If you have a calculator, that's how you do it. All right? So that way you save yourself this issue of, I don't know what the cube root of this number is. That's the way you would go about doing it. So it's x and 5. What is this first set? X plus 5. It's got to be the same sign. And then what's the next set? X squared minus 5x plus 25. Okay. Any questions on that? I'm going to give you one additional one to try. Let's go 8x cubed minus 27. You can do it. I believe in you. I believe in you. I'm going to press pause. If you're at home, you can press pause now as well. Let's try that. We're back. So, what times what gives me 8x cubed? That's 2x. What times what gives me 27? That answer is 3. Small, big. Here we go. This sign means this sign here is minus. What are we going to use? 2x minus 3. Now, what times what, or excuse me, 2x times 2x goes here. 2x times 2x is 4x squared. Now again, all you got to do to check that is just say, look, 2x times this has got to give you 8x cubed. And some people choose to do it that way. 2x times what gives me 8x cubed? And put it right there. 3 times 3 goes on the end. That's 9. Again, you can check it by saying negative 3 times what gives me 27? 9. What sign's going to be in the middle here? What sign is in the middle? Plus. Why is it plus? It's got to be opposite of this one. Okay. What's the term in the middle? 6x. And you're done. And you're done. Okay? Now again, what I hear from students a lot is, I don't understand it. There's not a whole lot to understand. You just kind of have to know this is the way it's done. Like there's some stuff that I want you to understand kind of how it comes about and where it comes from. This is kind of just a formula that either you do it or you don't. Okay? There's no real in-depth knowledge that comes from this. Now there's some other stuff that we can get into, but I'm not going to do that. Any questions on the sum and difference of cubes? With that being said,